Hello everyone, this is Mtabis Mshango, and we are back again with our November 2023 Physical Science Paper 2 review. And today we're looking at question 3, which is about physical properties of organic substances. Now, the question read as follows: the relationship between boiling point and molecular mass of aldehydes, carboxylic acids, and primary alcohols was being investigated for CAF-P, R, and CAF-S that were obtained, and all of these compounds were straight chain models. Now, we look at the graph. It's an increasing trend from left to right. So the trend that you see here is that the lower the molecular mass, the lower the boiling point, which is going according to this graph. So now, in 3.1, they ask us to define. I don't like writing down definitions, but just talk it out. Say define the term boiling point, and you must know that boiling point is the temperature at which vapor pressure equals atmospheric pressure. Okay, then in 3.2, we say write the conclusion that can be made for CAF-P. Now, there's so many conclusions that you can draw out here, but as we have seen that CAF-P is probably one of the compounds with a maybe stronger intermolecular force, you can make a conclusion, a simple conclusion like the greater the molecular mass or molar mass, in P, and the greater or the higher the boiling point. Alright, BP for boiling point, and this can give us a conclusion that therefore CAF-P is a carboxylic acid, because you're just making a conclusion here without further explaining. So we'll stop right there. And then in 3.3, they ask us to explain the answer in terms of structures of the compound. Now, this is according to what? Structure. Now, if we're going to look at structure, we were given that we have 3 types of homologous series that we're looking at here: aldehydes, or right al for it, and carboxylic acid, and primary alcohol. And if we look at the increasing trend of the strength of intermolecular forces, we would say this one is the least, so it's number 1. This one comes second, and this one comes third. Now, the question in here says explain your answer for CAF-P in terms of structure of the compounds. So a conclusion that one can make here is that As the chain of the structure increases, the boiling point increases. That's conclusion or an explanation. As the chain of the structure increases, boiling point increases as well. But you're not done because the question is not quite clear as to the structures of the compound and what. So you have to, after having made a conclusion and dropping to it, sorry, I think I will 3.4 here instead of 3.3. Okay. Now, we made a conclusion that this is a carboxylic acid, and we know that the structure has what? Two sides of hydrogen bonding. So the structure has two sides of hydrogen bonding because it's what? The carboxylic acid. And an alkyl side in the chain that grows as we move from left to right, which means the greater the molecular mass, the greater the alkyl side, which brings in what? It's not only hydrogen bonding that is present here, it brings or increases, which increases this alkyl side, which increases strength of um, an alkyl substituent on alkyl side would give in strength of what? Of the London forces. And we know when it comes to alkenes, as they become longer, their London forces become stronger, and therefore this increases. So we're making a conclusion here that thus this results in an increased boiling point. Increasing boiling point. I know for 2 marks this is something very long, but in this explanation you have to state everything that is quite possible because clearly the structure of this question is now changed from what it was used to be asked before. So it's safe to include so many things like this because markers would then look for those key words and key points in whatever you've written in here. Whether you write it in bullet points, well, bullet points they tend to be straightforward, so maybe they'll mark the first two. But if it's an essay like this, it talks of everything holistically. So I think it's safe to write it like this. Um, then in 3.4, they say we're looking at Cap R, and they tell us that Cap R is an alcohol. So definitely, as I have included my 1, 2, and 3 in terms of strength, and we made a conclusion in 3.2 that P is a carboxylic acid, and then that makes R a alcohol, and then S a by default would be what? An aldehyde. So 3.4.1 S is a what? Is an aldehyde. 3.4.2. Explain your answer to question 3.4.1 by referring to the strength of the intermolecular forces. Uh, Why am I saying this one is a maldehyde? P from 3.2 is a carboxylic acid. And R is stated that is a alcohol. Then by default S is an aldehyde. So strength of intermolecular forces. P has hydrogen bonding with two sides of the hydrogen bonding. S has hydrogen bonding with one side. And oh no, not S. This is what R. And S has dipole, dipole as its strong um, intermolecular force. So with S having dipole, dipole, these are weaker. Dipole, dipole here are weaker than hydrogen bonding from R and S. Therefore, compound or compounds in S so we would say therefore the compounds in did I say R and S? It's R and P here. R and B. Compounds in S will have a low boiling point. Boiling point. I'll write BP for that. Then compounds in R and P. Why? Because intermolecular forces at S are weaker than intermolecular forces at R and P compounds, which means less energy is required to overcome the intermolecular forces at compounds in S. Let me leave it that way. Let's see if we have Alright. Question number 3.5. 3.5 has a 3.5.1. Excuse me. Which says for curve R, which belongs to the alcohols, write down the molecular mass of the compound with a boiling point of 97 degrees Celsius. Molecular mass. Okay. We'll scroll all the way up to extrapolate. Where is 97? For curve R. I think a ruler maybe would help us here. How do I forgot? How do I? Oh, yeah. There it is. If you're looking at 90, okay, the scale here would be feet 50. Okay, so 0, 10, 20, 30, 40, 50. So this would make our 97 to be somewhere around here, and then this gives us a clear extrapolation to here, which is somewhere around let's take our ruler, around here. That's 50, 52, 54, 56, 58, and 60. So molecular mass that we're looking for 3.5.1. Just gonna write it here and take off the ruler. 3.5.1 molecular mass is 60 grams per mole. Then I'm going to take this back. Triple 5.2. The IUPAC name for the compound in 3.5.1. So I don't know if I needed to use here a systematic way or mathematical method, but since I know these are alcohols would start at methanol. Now we know methanol. I'm going to go with this structure rather than calculating the molecular formula. Okay, methanol has an OH, and there's the H's, which means methanol would have 12 plus 1, 2, 3, 4 plus 16. That gives us what? 32. 12 plus 4, 16, 16 plus 16, 32. And then if we go to the next alcohol, that would be your famous alcohol, which is ethanol, which is 12 times 2 plus 1, 2, 3, 4, 5, 6 plus 16. So now 12 times 2 plus 6 plus 16 would give us a overall molecular mass of what? 46 gram per mole. Then 1, 2, 3, 4 OH. This is what? 12 times 3 plus 1, 2, 3, 4, 5, 6, 7, 8 plus 16, which is equal to 12 times 3 plus 8 plus 16, which is equal to 60 grams per mole. Now, what is the IUPAC name of that structure then? Let's redraw the structure now fully with everything in it. Remember that in the statement they told us that these are all straight chain molecules, so there is no in straight chain molecules of what? Of primary alcohols. So you would have to go with what? If the structure is here, this is 1 propanol or propan 1 butter. Now 3.5.2. What is 3.5.2 asking us? Oh, that was 3.5.2 IPAC name. So it is 3.6. Now in 3.6, they're asking us of two compounds, A and B. That are used in this investigation, which have a molecular mass of 74, both of them, and A has a boiling point of 118, while B has a boiling point of 142. Explain the difference in their structures. Or difference in boiling point by referring to the structures of the compound. First, what you only know is the molecular mass. And if we go about it, already looking at B, or from 3.5.2, how we're deducing the molecular mass and comparing it to structure, it's easy now to find the one of 74 because we stopped at what? At carbon, with 3 carbons, right? So if we say 1, 2, 3, 4 OH with the H's here, this would be a 12 times 4 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 16. Now 12 times 4 plus 10 plus 16 will give us 74. Then for our compound B, or compound A, we need to know that which one is compound B and which one is compound A. So let's try and find out where do we get a molecule that has molecular mass of 74. 74 is something here, and we can already see that this goes back to here. 74 takes us to here at around what is this boiling point? We're given these two boiling points, 118 and 142. So this would be one somewhere around 118 because it's here it's 10 and then 120. Then the second one that has 74, which is from compounds in P, is here at around 142, which is right here around 142. Now it means we need to also find out what would be the structural formula for compound P. Right. Of course, we have to start from the bottom. Twelve plus 16 times 2 plus 2 is 46. What about if there are two of them? So it's 3, C double bond O for each. That will be 12 times 2 plus 16 times 2 plus 1, 2, 3, 4, 0, 4. 12 times 2 plus 16 times 2 plus 4 would give us 16. Maybe it is the third one. C, C, C double bond O, O, H. Alright, now that will be 12 times 3 plus 16 times 2, then plus how many? 1, 2, 3, 4, 5, 6. That gives us 74 grams per mole. Now we're comparing what? These two compounds here. 1 butanol versus propanoic acid. So first have to make a conclusion. Which one is compound A? And we try a compound B. The one with 142 comes from the carboxylic acid. So this one, 142 degrees Celsius, boiling point. Alcohol, 108 degrees Celsius, which makes this one compound A and this one compound B. Now, what did the question ask again? Explain the difference in these boiling points by referring to the structures of these compounds. So now we know the names, we know the structures, we know that this one has 4 carbons, this one has 3 carbons. But based on their structures, compound A has hydrogen bonding and is an alcohol, while compound B has hydrogen bonding and is a carboxylic acid. Um, Compound A has one site of hydrogen bonding because it's a what? It's an alcohol. And compound B has two sides of hydrogen bonding because it's a carboxylic acid. Therefore, compound B has stronger intermolecular forces than A due to the two sides of hydrogen bonding, and therefore more energy is required to overcome the intermolecular forces at compound B than at compound A. And that's where we'll stop for today. Please continue watching our videos, liking and sharing. Appreciate the love. Thank you.